Hello everyone, I'm Vicky. In this video, we will dive into the second part of our tutorial series on simulating the League of Legends game client interface, focusing specifically on constructing the slider. A slider is made of essential components like the track and the song. These elements are not just the parts of the slider, they are deeply integrated into the slider class. When considering the customization of this slider into a unit control, it's vital to understand these key components. Equally important is having a solid understanding of the standard slider template provided by Donut, including its structure and internal workings. If we gain a thorough and accurate understanding of these components, it will greatly enhance our perspective on WPF and expand the range of techniques at our disposal. In this video, I will take you through an in-depth exploration of the slider structure and components. By the end, we'll have a crafted slider custom control in the style of League of Legends. I've also uploaded source code on GitHub, so if you feel this video is useful, don't forget to give a star of work as you explore and download. Okay, now let's get started. Okay, let's create a new project. Choose WPF application. And name the file demo app. And then we choose the latest version 8.0. Okay, first we go to main window and add a slider. As we can see, this is a basic slider, a combination of the track and the song. But before we start writing the League of Legends slider, let's first get familiar with some basic properties of the slider. We just saw that is a slider's basic orientation is horizontal, right? Next, let's change it to vertical and have a check. Now it becomes a track that can slide up and down. So this is one of the properties concerning the slider's orientation that we need to understand. The second is we can set a minimum and maximum value for it. We set the minimum to 0 and maximum to 100. Then we switch the orientation back to horizontal. Running in this state, nothing will appear. But of course, to reflect this value, we need to add a value. We set it to 30. It then shows a position of 30 in the range of 0 to 100. And if we adjust the maximum value to 50, it will show a position of 30 within the range of 50. And we can also define the start and end points for the slider selector position using selection start and selection end. And let's set them to 20 and 60. At this point, we won't think anything, because to make it visible, we also need to use the isSelectionRange enabled property. So we set it to true to enable the slider's volume selection range feature. Okay, now the range we set is visible, but it looks a bit odd because we haven't changed the maximum value. So let's adjust it. Alright, now the 20 to 60 range is distinctly displayed, but it only marks the range and doesn't really affect the functionality of the slider. So how can we make it move along with the slider thumb? Here we can add a binding to selection end with the relative source object we set to itself and the path set to value. Okay, now it can move along with the slider thumb, right? Okay, above we explored some basic properties of the slider. Next, let's take a closer look at the source code of this basic slider to understand its internal structure. So we select the slider in main window. Right-click, choose Edit Template, then Edit Copy. We could rename it, but I will keep the original name at this time. Then we can choose how it's defined. Well, let's pick Application. Okay, we open the app.xaml file. we see it contains quite a lot of content. At the bottom, we can find the slider style section. As we mentioned, the slider's basic orientation is horizontal, but it can be altered to vertical, and this section precisely describes that motive action. The template is set to slider horizontal, and it changes to vertical orientation through a trigger. So let's press F12 to inspect the style's content in detail. So this part details the specific content for the horizontal, and it's the same for the vertical. Then we're back to main window to have a check. Here, the slider style has already been automatically linked for us. So if we change it to vertical, it will automatically switch to the vertical style through the trigger. Okay, let's back to the UpDesmo. And there is a lot of codes, but it's not necessary to decipher each line because it's a basic style provided by WPF containing the template, meant to be versatile to meet different development needs. And today we will focus on the country template section, taking slider horizontal as an example. We noted that some of X names start with a par underscore, such as par selection range and par track. This is a part we need to pay special attention to. In fact, we will talk about this part in the last video navigation bar, and today we will delve deeper to understand it further. Inside the slider country class, the on-the-play template is used internally, so this part is essential. So what will happen if we forcibly change or delete it? Let's add a 1 to par track, change the orientation to horizontal, and have a check. The slider cannot move anymore. That's because once name is changed, it can no longer locate the content of the track part. So when we're using it, we must correctly include in par underscore track to ensure its functionality works properly. The same goes for par selection range. Let's add a 1 to it. But in targeted par is also in use, so we add a 1 here too. What happened this time? The selection range par certainly won't display, right? So only when it's par underscore selection range can the C# code handle internally. So it's not something we set, but a native form within WPF. So par followed by an underscore is a convention we must adhere to. So when we customize it in the future, we must also define it in this manner to be able to utilize this inherent functionality provided by slider. So next, let's delve deeper to understand what the internal structure of par selection range and par track really looks like. To do this, we need to go inside the slider. So we press F12, but this is a bond-in a DLL that we can't immediately see the old code. So what can we do? Actually, we can conveniently view the source code on the GitHub. First, go to the address, then to .NET WPF. All the code related to WPF has been uploaded here. Then how do we quickly find the part we want? We can press the dot key on the keyboard, and it will automatically switch to Visual Studio Code mode. So in this way, we don't need to use a Git clone and can still view the code very conveniently. Here we click the search bar on the left and enter the content we want to search for. Let's give it a try. Okay, the part selection range is used in many places, and what we need here is in the slider class. Okay, it's here. But it's not the attribute we are looking for, so let's search for something else. Because the part selection range is placed inside the element name, so we can proceed to search for the selection range element. Here is an on-the-play template. When the style template and the class are connected at this node, the override method on-the-play template is invoked, and below that, both the selection range element and track are ready. And we can see the getTemplateChild for selection range element is a selection range element name, and getTemplateChild for the track bar is a track name. Then track transforms the object into a track, but selection range element is slightly different. I'm not sure if everyone remembers, but as we just saw in the Visual Studio Code, it was clearly a rectangle, but here it receives a framework element. Of course, we could directly write it as a rectangle, but in doing so, we would be limited to use rectangles exclusively. However, we might also want to use a border or a grid, etc. And they all inherit from the framework element. So that's why a more general superclass was specified for use here. Moreover, selection range is just meant to mark a range. It can be placed anywhere, which is why it utilizes a framework element. Okay, so next, let's see where is the selection range element and track are actually used. Just above, there is an onValue changed callback method. Here, every time the slider's value changes, onValue changed is invoked, and this part must have a trigger to process selection range element. So, is this update the selection range element position and size suspicious? Let's take a look. As expected, it involves both the track and the selection range element. Looking further, when range element is null, it automatically returns. That is, after we changed the name, it couldn't find the past selection range, so it becomes null, and the process automatically ends. This means that this series of codes below will not run anymore, because the selection range is already set up above, and the range element is invoked in so many places below. Therefore, when the orientation is horizontal, the range element adjusts its west. Conversely, the else below is for the vertical orientation, where the range element adjusts the demand of the height. So part selection range is derived from such logic. Of course, there's corresponding code for part track as well. And if anyone is interested, you can also look it up and study it. So in summary, dissecting the internal source code and mastering its structure is a very beneficial process for learning, understanding, and later customization. James and I also learning continuously through this method. This process often provides us with the inspiration and has been very helpful in our research. So if similar parts appear in our subsequent videos, we can discuss them in detail. Alright, next we're officially moved to programming the League of Legends slider. Okay, first we create a WPF custom control library. Name it Slider Control. Sticking with version 8.0. As before, since we're rebuilding, so we delete the auto-generated assembly inform and the custom control. Then we add a new class. Selecting WPF custom control and name it. Here we can see as we create a new class, it automatically generated the necessary assembly inform and generic for us. Then we can remove the parts we don't need. Next, we replace control with the slider. Then moving on to generic, here we are at a test block to test it out. And before running, we need to add this project reference. Also, we can delete the original content in main window. And the code in app.xaml is too long, and we will keep it simple, so I will remove this part as well. Then we add our Riot slider to main window. And run it. And then we should be able to see the content we entered. Okay, the test part is complete. Now let's get started. First, we set the width to 200 and the height to 50. Then select a background color. Here, I will set the color to transparent. Okay, next we move on to the track section. We add an ellipse and set its size to 24 and define a fill color. The track is currently cannot move, so it's important to add a next name we found in the code. Part on the circle track. This allows the slider class to handle it through on a play template, making the circle slide. Then we add a slider bar, which needs to overlap with the track, so we place it inside a grid. In the grid, we add a border with a height of 2.5 and set a background color. Okay, to better understand the position relationship between two elements, we can add some transparency. Now, if we observe, the bar appears above the circle. However, the bar's starting point is actually at the circle's endpoint. To make the slider more natural, we prefer the bar's starting point to be at the circle's center. So we adjust it by setting a margin. The circle's diameter is 24, so we set a margin of 12 on each side. Okay, now let's handle the selection range part. Like before, we add a border, set the height to 2.5, and choose a black for background. To activate the slider selection range, we must name xName as par underscore selection range. We also name minimum, maximum, selection start, and selection end. We put selection end at 50. But it defaults to center, so we align it left. But do you remember initially we used an is a selection range enabled property to display the selection area, but here without adding it, the area still appears. Why is that? Since we redefined this slider, the previous triggers disappeared, which is why the area is visible without adding anything. But if we want to refine this part, how should we proceed? First, is the selection range enabled property is currently set to false. Then we'll proceed to set the specific triggers below. The property is a selection range enabled, and when the value is true, the target name, par selection range, visibility, change to visible. We also need to set a default state. For the border, we set the visibility attribute to collapsed. As our current state is false, nothing is visible, so we need to change it to true. And then we add a binding to selection end to make it and move its value. Alright, with that, the basic functionalities of the slider are now set up. Currently, the code structure appears quite messy, so let's tidy it up together. First off, we don't actually need this border, so let's decisively remove it. However, we do want to retain the background property. So right here, let's add a template binding. Okay, move on. There's quite a bit of a repetition in this section. So to address this, we can place these two borders inside a grid. Next, we add 2 columns. We'll set the first one to auto and the second one to a star. Then let's put these 2 borders inside. But here we need to make some adjustment. First, regarding the height, we'll centralize with a grid. And since our first column definition is ready to say the auto, this horizontal alignment can be omitted. Alright, we're definitely going to use the selection range, so the visibility here can be removed. And this trigger, and the property above. Okay. And the margin, we can place it at the top. And then over here, I usually prefer to position the name at the end. And don't forget the gray column numbers 0 and 1. Let's run it. Okay, no issue. Now the code is much neater than before, isn't it? Okay, now let's move on to setting up the sum part. Before we proceed, let's delve into some detail about track. Track inherits from framework element, so it doesn't have a template. And inside it, it automatically associates with a sum, meaning the sum we've been using was added within the track. This is like adding content to a button, but content is of type object, so it can contain anything. However, you can assign a slider using test, so we need to expand the syntax and then insert a slider, like this. This principle applies to track, although there's no issue with the code logic, but we can write it like that in XAML. The correct way should be like this. But constantly expanding it this way is too cumbersome, so we can make the sum a static resource, displaying the sum style, allowing us to present it in just one line of code. So the conclusion is, in a domain of resource dictionaries, is not limited to defined styles. Resources like thumb can also be defined, including geometry, solid color brush, and so on that we have tried before. All follow the same concept. So let's produce to write this section based on this logic. Okay, first let's add a style directly above. Here, X type is sum, and we define X key at thumb style. Set a property template. Contra template and target type sum. Here we need to replace the circle with a special shape, so we add a path. Here you can directly copy the data from our source code. We add a geometry above the X key sum data. Then we can directly put this data in. And then we connect the path to some data. Set the color to brown. Then we set the size of the path to 24. Then we add a sum below. X key, slider sum. Style, we'll use static resource, sum style. Then we go back down. Here we don't need to extend the code, so we can abbreviate as track. X name, part track. And then directly insert the sum and using static resource to connect it. That's it. With this, our line of code is complete. Okay, it's worked. And then to make it clear, we can change the background color. The color of the selection part should be more striking, so let's do a change. Okay, looks better now. And look at here, because the stump shape is hollow, we can see the lines of the bar behind it, so we need to address this part as well. We go to stump style, add a background that matches main window's background color. Then we add a grid to put the path into. And finally, we add the template binding to the background. And that should do it, right? Finally, we just need to handle the color part. In the League of Legends game, the slider's color consists of a series of gradient colors. So just like we did in the play button video, we'll use a linear gradient brush to add the gradient colors. You can refer to that previous video for the specific method, but here I will quickly write it down. First off, we call our base color sum color. And then we need a start point and end point. Next, we add a specific color with a gradient stop. And finally, we set the color positions with offset. And then we put the color in here. Next, we also need to add triggers for its mouse over and its dragging effects. So first we need to add a next name, pass. When its mouse over occurs, it will change to different color. Target name, pass. And property, fill. Static resource, sum over. Then we go back to specifically set the color for sum over. Since the method is same as before, so I will directly copy the prepared code in here. Okay, mouse over is complete. Next, we'll handle the extracting part. Similar to mouse over, we'll copy the content and make some modification. Here we call it sum drag, and then we add the gradient color in. Okay, this part is also completed. Next, let's handle the color of the slider's track. Since it only needs one color, so we can add it using a solid color brush. And then connect the code. For the selection range part is also a gradient color, so we add it using the same method and we call it range color. With that, the basic color are set. Then we're moving on to the slider template. We also need to set the triggers here using data trigger, binding, element name, part track, and pass thumb is mouse over. When it's true, part selection range, background color, change to slider over. Then we come up to set the specific color. Let's have a check. Okay, it's worked. Next, we apply the same method to complete the Easter egg part. Replace mouse over with Easter egging. And the name of static resource also need to be changed to slider drag. Okay, it's worked. But there's an issue. When we randomly click a position on the slider with the mouse, it doesn't get recognized correctly, so we need to address this part as well. But before that, our current code is quite complex. And in fact, we can simplify the code using Jamesnet WPF NuGet package. First, we add the library to our project. Then we can replace the existing grade with James grade. Setting rows to star. The first column to auto and the second column to star. The section below, then we can directly delete it. And of course, we no longer need the grade column settings. So now, the code for this part looks much neater. Okay, finally, we return to that issue. We add in a smooth to point enabled property here. And when we set it to true, clicking any position on this slider will move the thumb to the corresponding location. Okay, that's all the content for this video. I have uploaded the source code on GitHub. If you find this video helpful, don't forget to click the star and forward while downloading and browsing the code. We'll continue to upload more high-quality WPF tutorial videos, so don't forget to follow us. I'm Vicky. See you next time. Bye-bye.